A very good evening to everyone who's tuned into this live session on YouTube or is watching this on Instagram. My name is Samarthan Farmer, and on behalf of Team Roverx, I welcome you all to this live session where we talk about the planet Mars and the search of life beyond the blue planet. In 1962, John F. Kennedy told us that we are going to put humans on the moon, and he inspired an entire generation to dream. Today, about 60 years later, we stand at the threshold of embarking upon another extraordinary adventure, exploring the possibility of life beyond this pale blue dot. With NASA sending its fifth rover to Mars, private organizations finding their foot in the space race, we are much closer than you expect to achieving this great feat. Today, we are here to discuss how, as a human race, we aim to pursue this intergalactic endeavor. This webinar will be answering questions about extraterrestrial life, what scientists have understood so far, and briefly about how much of life is carried out on the components and instruments being used for it. Before we move ahead in this session, I would encourage you to be interactive. Feel free to type in your doubts or questions in the live chat below.
Good evening, everyone. It is my pleasure to introduce today's speaker, Mr. Gaurav Banerjee. Good evening, sir. Mr. Gaurav Banerjee is a research scholar in astrophysics from Christ University, Bangalore, and has a lot of experience in his field. He has written a book on astronomy for children and how can one pursue a career in astronomy. He is a founder member of Kolkata Institute of Fundamental Science and Astronomy. Mr. Banerjee is passionate in popularizing astronomy and has delivered more than 100 popular talks in astronomy in different parts of India. We are very delighted to have you here with us, sir, and we are very excited and eager to hear from you.
Thank you, sir. Thank you. Shall I start now? Can I present it?
Yes, sir.
Yes,
please.
sure.
Okay. So let me present the screen. Well, now is it visible? I hope this is visible.
Yes, sir. It's visible. You may start your presentation.
So I will close my video so that no problem will be there. Right. So good evening, everyone. First of all, I would like to thank Bangalore Institute of Technology and especially Team RoverX. So I came to know about this team around few years ago when in 2015 I got the news that Team RoverX from VIT, they have designed one or developed one prototype for Mars, which is a rover actually, and they have been achieved or they have received the first prize in Asia Pacific region in European Rover Challenge. So from then on, actually I am trying to follow their activities. So it's a great pleasure to be a part of this talk today with Team RoverX from my part also. It is my delight, it is my pleasure. Thank you, and thank you all the organizers for arranging this talk. So as my talk will be basically on Mars. What about Mars? So I would like to discuss a very few points. Mars is something which is delighting us, which is challenging us for the past 2000 years. So I have taken a small portion of that, which I would like to share with all of you. That is about basically how search of life has been carried out, taking Mars as a baseline or taking Mars being a cosmic stone or stepping stone of cosmos. So if I go to that history that I told before, that 2000 years ago, or might be whether it is written or not written in history, from the day onwards when first human beings appeared on Earth, I hope that due to natural curiosity, they are looking towards the sky. Especially the night sky was dazzling. And this is a view of the night sky which you can go or you can have if you go to some of the darkest places of Earth. So just think about 2000 years ago or 1000 years ago or during the prehistoric times when people used to look at the sky, obviously it was more beautiful. We unfortunately do not see such type of sky from cities, so we have to go out. But whenever you go and see such a sky, naturally due to curious minds, what we are blessed to have this curious mind, humanity. So we naturally, so many questions come to us, and most of them, those questions during so many years, these are not solved. This remains as huge philosophical questions. If I come to some such questions, we will see that might be these were some questions which were asked by our predecessors, and then our predecessors to predecessors, might be the prehistoric period people also, but without any answer. So till now, these are some of the greatest questions which we want to solve, which we want to know us, to know about our world, to know about the cosmos. And I feel among all these questions, the last question or the few last questions, how big is the universe or what is life, especially are we alone? Are we alone in this universe? Are we alone in this solar system, first of all? How big is the solar system? So this are we alone? This question is some kind of, it has become like a passion to so many people. It is a fantasy, it is a fiction, it has come to the minds of maybe so many people, which are written or not even written in history. So if we go to written history, we will find that speculations whether we are alone in the sky or in this universe or not started right from the beginning of modern era, or before the modern era, even before the birth of Christ. So around 400 years ago, before the birth of Christ, according to written history, Metrodorus, he was the first person, he was a Greek philosopher, who wrote like this, that it is unnatural in a large field to have only one shaft of wheat. And likewise, and in the infinite universe, only one living world. Just try to understand, try to think how logical this question was or this writing was during those times when we had no technology, nothing, no science, no modern science, almost nothing. Gradually, this question evolved. This came to the minds of so many people. And as many of you might know, that during the 16th century, especially at the start of 17th century, 1600 especially, so on 17th February 1600, one person named Giordano Bruno, he was a young scholar, he was a young philosopher come scientist, we can say. He was very bold, he was very courageous, and very courageously he used to propose, or he used to actually advertise this idea that we are not alone in this huge universe. But during those times, no one was ready to believe him, no one was ready to take him. And those were the times which were ruled not by science, mostly by superstitions. So on 17 February 1600, this person, or I will rather say this bold young lad, was burnt alive in the roads of Rome, present day Italy. But the try or the search never stopped. So if we go on looking like this, we will see that this question has haunted some of the greatest minds of our earth, whether it is the mathematicians like Carl Gauss, whether it is the greatest physicists, one of the greatest physicists like Nikola Tesla. They all tried to attempt or attempted through their own merits that we must find somebody. We cannot be alone in this huge universe. Now the concept of hugeness also was increasing day by day, and gradually knowledge and science was also increasing. So nowadays, if you come to the basic books, or suppose basic biology books or school books, and if I ask the question, what is life? What you will find, let us see, come back from those earlier days, directly jump to the modern days. What is life? If you see any general simple biology school books, you will see that some properties of life are mentioned. And by definition, it is shown that, okay, life is something which can grow, which can develop, which can utilize energy for metabolism, which responds to stimuli or responds to environment, which reproduces, which has structural order of cells. Well, these are all some of the characteristics which I am talking about life. But you can see everywhere there is a controversial aspect, or there is a counter attack. So when one tells that, well, life grows, then what about fire, spreading fire? That also grows. When one tells me that energy utilization is done by life, what about a car? When one tells that response to stimuli, then this is also done by mercury thermometer. Structural order of cells, you will see much more better structural order of cells or constituents in case of salt crystals. Reproduction, the counter attack is very simple. What about unmarried persons? Also, there are creatures, some creatures which do not reproduce. So what is actually life? Basically, if we deep try to understand what is life, we will understand, or we will come to the conclusion through biology that the definition of life does not exist till now. Whatever we are telling here, we are actually telling that the basically the characteristics of properties of life we see in our own earth, not anywhere else. So then what to do? Basically, when we were gradually, or scientists were gradually understanding that by this process, we cannot understand what life is in our own earth also. So they took the help of physicists. Physicists tried to define life with the help of thermodynamics, that is heat and energy, and their relationship to matter. Later, if you come to 1944, this famous physicist Erwin Schrödinger, he wrote one of the first classic books on what is life. And this is a famous book. This is currently also available. He tried to explain what is life with the help of a concept called entropy in physics. I will not go to any details of these things. So that means we are watching that from biology, people gradually shifted to physics. But ultimately, we didn't find any result. Success was not there. Again, whatever we found, the answer came out to be like this, that we are trying to explain life by watching what we see, the properties of life in our own earth. So when physics cannot help, when biology cannot help, what we can do? Then we had to take the help of geologists. And after going through our evolution of life or history of evolution of life in our earth, we have found that the earliest life forms which are present in earth, they date back to some periods of around more than 350 crore years away. So this B is actually billion years. 1 billion is 100 crore. So we can calculate that the earliest format of life, which are known as basically stromatolites. So basically these stromatolites were soft-bodied organisms. They were not like us. They were not like human beings or a dog, goat, elephant, not like that. They were primitive life, extremely primitive life, and we have identified or found fossils of those particular primitive life. So these are some of the examples of such primitive life which we have found in various places of our earth. And the oldest life form dates back to more than 350 crore years. So our earth or our solar system, as we know, that our earth is having an age of around 450 or 460 crore years. And this is where we find evidence of life. So we know that 350 crore years ago also, there were primitive life which were existing in various parts of the world, obviously in water. But do that help us to understand what is life? No. Again, no. Why? Now come to this thing. See, as we were progressing, science is always full of wonders. So during 1960s, 1970s, as we were getting more and more technological support, scientists started finding life in some places of Earth which we never thought of, which we call as extreme life or extreme places in our Earth. So this kind of life which can exist in extreme places of our Earth are basically known as extremophiles. What are these? So what kind of life is this? Just see this slide, you will gradually become amazed, I feel. See, there are lives which are known as barophiles. These are extreme organisms which lives at high pressure. And some can live inside the hydrothermal vents or in fissures, in fractures inside the sea, at such depths where the atmosphere or where the water pressure is 1,000 times more than that of Earth's atmospheric pressure. Think about some extreme organisms like these, second, halophiles. They live in salty medium, 1/3 as salty as seawater. If any general life form tries to live in such a salty medium, they will die, definitely. Have you seen rocks? Can you understand? Can you ever believe that inside rocks there are pores where there is no water, no temperature difference, nothing is there, no food, and we find inside those pores of rocks, we find life. Also, we find life at extreme temperature conditions. We find life inside acid lakes. We find life inside ionizing radiations where these lives can actually resist themselves from radio ionization or ionizing dangerous radiations. So if such kind of variety of life can exist on our own earth, then do you think that we have properly understood what is life? No, we don't. So suppose if you get some life which comes to you and tells you that I don't need oxygen for my survival, but I also follow all the rules what you have written in your book, and I am also alive, then how will you search life outside Earth? We don't know what is life inside Earth. So this actually gave rise to a concept that we first should identify what are the ingredients which are necessary for life in Earth. Then we can look behind or beyond Earth. And through the help of chemistry, physics, biology, almost every branch of science has contributed, almost every branch of explorers have contributed for years. So ultimately, we found out that, see, basically, the bare necessities of life can be or are basically like this. Only 6 elements are necessary for most of the life forms which are present in Earth. What are these? The CHNOPS. This basically stands for 6 elements: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. I can give you a bet, or I can guarantee you that whatever life forms you take, 99% of the life forms in our Earth will have major 6 components in their bodies, and these are the 6 elements. So when we have ultimately got hold of these basic ingredients of life which we need in Earth, now basically we can actually try to search life elsewhere. But what will happen? Suppose what will happen by spending so much of money? What will happen if we find life elsewhere apart from Earth? Will it help us somehow? Obviously, it will help us, because first help it will give is we will understand what is life first of all. We are life and we don't understand who we are, where we come from, how life can exist, whether life is an accident, whether this is the only place where life can exist. So if you need to go out someday in maybe long gone or long future, that you have to vacate your own home, that is Earth, where will you go? Or where will our next generation go? So we need to find a home. It is important to know us. It is important to know the origin of life on Earth. It is important to know what is life first of all. And obviously from science point of view, it is important to know that whether Earth is the only place in our maybe our whole universe where life is getting such kind of opportunity. So we know that in science accidents happen, exceptions are there, but till now we haven't found any miraculous accident happening. But according to our present understanding, life in Earth is supposedly like a miraculous accident. We need to identify whether physics, whether the science we understand is correct or not, whether miraculous accident like life has happened only in case of Earth. So these are some important questions we can solve if we find life elsewhere outside Earth. Now, to find life, what we should do? See, for finding life outside, first, what you have to do is you have to find planets. And there are many number of planets which are basically known as exoplanets. So any planet which we are finding or which we can discover outside our solar system, basically these are known as exoplanets. There are so many ways to detect such exoplanets. Presently, we have more than 400 exoplanets detected. In our own solar system, we have planets, also other solar system moons, asteroids. So basically, the first point is that we should find planets first, then only we can search for life. Now we know that yes, we have so many number of planets are discovered, and obviously with increasing technology, we will discover so many other exoplanets. Now, if you find life or if you find exoplanets or planets, that means you will search for life in that planet? No. Then you need a special kind of planet. Not only planets, you need habitable planets, planets where life can sustain. So how we define that habitable planets? Is there any definition of that? Understanding of our knowledge have given us an idea that in our own Earth, wherever you find liquid water, except distilled laboratory testing equipments or test tubes. So wherever we find liquid water in Earth, we have found life. So that means that gives us an idea. So this picture tells us, okay, basically if we find one planetary system in any case or in case of any star, we should search some place or some region in that system which is known as a habitable zone. So that means from the parent star, if the mass of the star is huge, more than our sun, then that habitable zone will remain much farther away what it is in our own solar system. And if it is a smaller star, that habitable zone will be much closer to the parent star than our own sun. By definition, habitable zone is that zone or that area in a solar system or in a stellar system where liquid water can exist. So inside this particular region or habitable zone of a star, if there is any one planet or two planets, then there is a probability that liquid water can be sustained in that planet. Here I have given the example of our own solar system. You see, there is something which is very interesting we can see. In our own solar system, you see the habitable zone of sun. Inside that habitable zone, only our Earth is situated. And we know that liquid water can exist in Earth. Just see the left-hand side and right-hand side of Earth. You see the planet Venus. It is a bit farther away from the habitable zone. And it is really like a hell. So we cannot expect, according to our present understanding, we cannot expect that life will exist there. But just see the right-hand side. Just see Mars. Can you see something fantastic? As if somebody has just kicked Mars out of our own habitable zone of sun. And this understanding gradually became a most important factor to study Mars. Obviously, during these times, Mars study is going on for years. But whether we have to study Mars more? Yes, we have to. Because Mars is the only planet in our own solar system apart from Earth which can have those aspects or those conditions where at least extreme life can survive, may not be like human beings, may not be normal life. And if that is the case, then we should look for it. We should look for life in Mars. So we know that obviously Mars has so many similarities if we compare the other planets with our own Earth. There are so many similarities. It is very close to Sun, like our Earth, and so many others are there. But let me go back to a bit history, that before understanding or before telling a brief about what kind of work is going on to search life in Mars or about beyond Mars, let me give you an idea that, well, Mars is not only important during these times, my friends. You have to understand that right from the beginning of history, Mars has played a crucial role in the development of science, in the development of physics, basically in the development of technology, space age, space technology, and as a whole in the development of humanity as a whole. How? Just see this picture. It was around 1500 years ago, or we know that around 2000 years ago. How is our universe? What is the model of our universe? What kind of universe we have? So basically, we used to believe, or people used to think, that our universe is modeled like this. Earth is at the center of everything, and everything, every other object or planets or other stars, everything is revolving around our own Earth. So this model, which was mainly first proposed by Aristotle and mainly popularized by Ptolemy, they were both Greek philosophers or scientists. So this model is basically known as the geocentric model of the universe. And do you know how this model was established? This model was so powerful that Ptolemy's model of geocentric concept, it continued to dominate the Earth for more than 1500 years. How can a model remain for 1500 years if it has no scientific merit at all? It had scientific merits. And Ptolemy took the help of Mars observation to actually establish this geocentric model. What we found was this, basically, in a very easy manner, that if you look at Mars, you will see that sometimes in the sky, Mars shows a backward motion in the sky. So you look like this, you will see Mars is here. Next day you see the Mars is here. Gradually it goes on like this. It will show backward. And backward motion of Mars basically is known as retrograde motion. Presently, we understand that this backward motion is not a physical characteristics of Mars. It is shown by any outer planet which is lying apart from Earth's orbit. due to the respective speed difference. So when Earth is moving, being nearer to Earth or being nearer to Sun, it is moving faster or it is revolving faster. So when like this, when Earth passes Mars, we as an optical we see as if Mars is going back. During 1500 years ago, this retrograde motion was not defined and nobody knew that we are actually moving. So by looking at Mars and by tediously calculations, this geocentric concept was established. So that concept we know was first debated in 1543 by Copernicus. He told, no, that is not the case. Sun is at the center and everything else is revolving around the sun. So how this concept, which is known as heliocentric concept, he was a theoretician. Through theoretical calculations, he wrote this or he predicted this. But who established it? Obviously, the works of Galileo, observational works of Galileo, and another person, Kepler. So Johannes Kepler. They actually established that whether that geocentric concept was wrong and heliocentric concept is basically correct. Miraculously, we'll see that it was again the same planet Mars. By observing Mars for years, Kepler established this basic fact. Kepler was the person who understood by observing Mars that every planet revolves around our sun in an elliptical orbit. And that actually gave birth to modern physics. This extreme discovery, basically three discoveries or three laws, as we know, Kepler's three laws of planetary motion. So this was discovered again by observing Mars. So you see, Mars has played the role of like a stage hero. It's like a showstopper. Anytime, every time when human beings needed some help from extra celestial objects, they have received either directly or indirectly, they have received the help from Mars. So if I ask a question like this, do you know about any one single celestial object which has helped for the development of humanity the most? The answer is basically Mars. Yes, it is Mars. So that's why I have discussed this issue, and it continued. So naturally, the first telescopic drawing of Mars was done by this person, Francesco Fontana, and you can understand this was not a very good drawing, but this was the first drawing with the help of telescope in 1636. So study of Mars, and as a result, study of our understanding went on. Study of our understanding of planets or our understanding of the sky went on through studies of these objects. And Mars took a very important step, or Mars took a very important, crucial role. So I will just come to this place now. See, it was evolving for 200 years. There were so many people, so many good observers who were actually taking or drawing Mars and trying to understand how is actually Mars. This is the first detailed map of Mars, which was made by Richard Proctor. So he was a good amateur astronomer, and it was in 1867. But gradually, like this, I will again come to this special person. It was in 1877 when Mars again came to highlights. Why? Before that also so many things have happened, but I will not take that much detail. I will not go to those details. So this Giovanni Schiaparelli was an Italian astronomer, and in 1877, Mars came to a very nearby to Earth. So this happens every 2.5 years, once Mars comes nearer to Earth, and once in every 15 or 16 years, Mars comes very near to Earth. This happens once in every 15 or 16 years. This position is basically known as opposition of Mars. So this particular time, which was technically known as perihelic opposition, in 1877, it happened in 1877, and Giovanni Schiaparelli, he had his own telescopes. He was a good observer. He took the opportunity and he started observing Mars. And he found some very odd objects, which he actually drew. He prepared a very detailed map of Mars where he drew structures like these. And in Italian, he wrote very clearly that I have observed some features in Mars which looks like canales. Now in Italian, this word canale means holes, Holes, holes. But miraculously, again, coincidentally, when this news spread to England and nearby English-speaking countries, the English-speaking countries took this word canali and they translated this word canali as canals. And another coincidence, my friends, see, during this same year, if you go to history of our own earth, you will see the famous Suez Canal of Egypt was also completed in 1877, the same year. So it was like a mega blast. People just started jumping with gladness. Oh my God. That means if canals are present in Mars, so canals in Earth are made by intelligent beings. Canals are channels. That means if canals are present in Mars, that means these are made by intelligent beings who are actually remaining or who are actually thriving there. That means Mars has intelligent beings. Mars is inhabited. And this was like a spark. It was such a spark that when Giovanni Schiaparelli observed repeatedly, he wrote also, there were some other people who wrote that, no, this is not the correct thing. Canali is not canals. Also, we are not claiming that people or human beings or intelligent life exist in Mars. Nobody actually, almost the whole world didn't believe, and the rumor spread more dangerously than the truth. And in that scene, during that scene, another person, Percival Lowell, so he was an American rich person, he was basically a billionaire. He was so much fascinated with these things that he left his own business and he started observing Mars with another person, with another astronomer. So basically, this Mars also shows us what happens when rumors spread. Basically, this Mars also shows us what happens when someone who is not an expert or in-depth knowledge, having no in-depth knowledge about a particular topic, suddenly jumps to that topic and starts publishing his own ideas. This is the same thing what Percival Lowell did. Indirectly, he also helped us, I will tell that. So what he did was, he was not an astronomer, he was a businessman, he had no knowledge about astronomy, but he was so interested about these rumors and all these stories going on for 20 years that he started publishing books and he's made his own telescopes. He started observing Mars and intensely publicized the idea that Mars is having life. Mars is having canals, and these canals are made by extremely intelligent lives which are actually there present in Mars, and everybody believed it. So you see, during the last half of this 19th century with Mars, people were actually every day getting some new news. And science was almost transformed into fiction during those days. This is the second image, is the famous book H.G. Wells' War of the Worlds. It's a 1906 edition copy. Like that, Edgar Rice Burroughs, the person who created the character Tarzan, this is one book by him, A Princess of Mars. So many, a flurry of science fiction books based on Mars, on life on Mars, were published during those days. If you go to those days, if you can go, that during 1898 or 1895 to 1920, you will see huge number of science fiction were written by various authors, and people were almost having sure belief that yes, Mars is inhabited. So these science fictions or this rumor actually helped in two ways. First of all, a group of serious scientists, they started trying to understand the properties of Mars, and gradually we found that yes, Mars actually has so many similarities with our own Earth. Its shape is same, almost same like our Earth, which is oblate spheroid. Its axial tilt is also just a bit more than our Earth. For Earth, it is around 23 degree. For Mars, it is 25 degree. It is also having little more amount of time it takes for rotation. It has also seasons. There are polar ice caps, clouds, seasons, sand dunes, volcanoes, sedimentary layers. Everything is present in Mars, which are also present in our own Earth. But my friends, we have to understand during these periods, I am talking about 1920s and 1930s, people were also understanding that there are ample dissimilarities also. First of all, Mars is almost half the size of our own Earth and gravity is very less. Second of all, see this composition, atmospheric composition. Mars is having so much amount of carbon dioxide, which is a danger for life in our Earth, maximum life. So like this, we were actually getting what actual science is and what actually Mars is. But in another way, these science fictions helped us. How? Well, this person, Werner von Braun, he has mentioned in his autobiography that during those times, he was a German basically. So he and so many people who were during those times young people or young children, they were so much fascinated by science fiction writings of those H.G. Wells, Edgar Rice Burroughs, and so many people others, that Mars is inhabited. They used to read those books, and so many of those young, brilliant minds later became space scientists, including this person, Werner von Braun, who was actually the mastermind behind developing the German V2 missiles during World War II, and later the Saturn V rocket system, which actually landed man in moon. So he was a pioneer of rocketry. He was a pioneer of space science for America. So this is how you see when the space age actually started. The space age starting or also had an indirect connection with Mars. And the first spacecraft which flew by Mars successfully was Mariner 4. I would like to tell that Mars expedition or Mars exploration basically was never easy. More than 50 missions have been carried out for Mars till now, till date, and you will see more than 60% of them have ended in failure. So it is extremely difficult to send a mission to Mars or any other planet basically, which is crores of kilometers away from us. If you go on, in 1971, this was the first spacecraft which softly landed, successfully landed on Mars. It was Mars 3. It was sent by Russia, that is that time USSR, but it was able to send us data for only 2 minutes. And the first spacecraft which actually orbited another planet and properly was Mariner 9. It orbited Mars and reached in 1971. And ultimately, we come to this period of Viking 1, the first spacecraft which actually landed on Mars or any other planet apart from our Earth, and actually successfully carried out its missions. So these sorts of spacecrafts till around 1980s have helped in many ways. See this, the first picture we have ever received from any outer planet, any planet surface apart from our Earth. This was taken by Viking 1. And what Viking 1 has taught us, this is a mosaic of more than 100 images taken from Viking 1. The first thing any spacecraft or any rover helped us or helps us to understand the planet is about the geology, the surface features, the features which are present in that planet. Like you see in this picture in the middle, you see something, and that something, that cracky thing is basically this. So this is the grandest canyon system we have ever found in our solar system. I have compared this with the topmost picture, which is the Grand Canyon of USA, which is in some places it is 5 kilometers deep, which is 150-kilometer length long. But if you compare this Grand Canyon with Valles Marineris, which is the grandest canyon discovered by Mariner 9, so that is present in Mars, it is 4,500 kilometers long. So this Grand Canyon of our own US will be dwarfed by this Valles Marineris. If you place whole America, the whole America will fit inside this Valles Marineris. We were actually numbstruck when we actually started finding what is present in Mars. What Mariner 9, apart from this, found was this. There are so many volcanoes in Mars, and one of that such volcano is Olympus Mons, which is the highest mountain peak in our solar system. So this mountain, compared to our own Mount Everest, is 3 times taller than Mount Everest and extremely huge. So you see Mount Everest is almost 9 kilometers high. Olympus Mons is 27 kilometers high. These kind of features, when we discovered, we understood that different kind of geology can be present apart from Earth in some other place. The understanding of geology in a broader aspect was given by Mars study and then later by studying other planets through spacecrafts. Also, miraculously, when Mariner 9 reached Mars in 1971, it observed one storm which is raging through Mars, and that was basically a global storm. So from 1956 to 2007, these are actually very rare in Mars. We have seen only 8 storms or global storms which hit actually Mars. This is one example for that. You see, in June 10, 2001, when we took a picture of Mars, we can see the surface features. After 1 month, when we took the same picture, everything is covered. And this covered thing is actually dust. So we actually discovered storms or global storms which raged through a huge planet. The whole planet covering storms we actually discovered. We understood what extreme climate can actually happen or occur in a place outside Earth. And apart from that, this Viking one also took a picture like this. Obviously, it was a stunning picture, not for scientists. They understood that this cannot be real. It looked like a face. And naturally, again, after 100 years, from 1877, there were common people who started jumping that, okay, it is looking like an exact face on Mars. That means life is there in Mars. Or some intelligent life was there. They actually made this architecture or sculpture. But basically, you see with the help of sophisticated instruments, especially cameras or imagers. This was taken by 1976 by Viking 1 rover with the help of his camera, whose resolution was very less. And gradually, in 2007, when the same area was captured by the high-rise camera of Mars Reconnaissance Orbiter. It actually resolved that place, and we ultimately observed that that is not at all a face. It is basically a indescript hill, and light is falling in such lighting angles, it appears like a face if you do not use a very sophisticated instrument or camera. So like this, Mars exploration has also helped in better understanding of technology. Then during 1990s, 1997 was a historical time when one particular spacecraft, Pathfinder, landed on Mars, and it actually carried a rover. This was the first rover which actually roamed on Martian surface. So this is how the rover looked like. It was named as Sojourner, and a new era actually unfurled in front of us. So Sojourner, and after that, NASA started sending its rovers. This we know, actually, this is Spirit rover, and Spirit and Opportunity 2 rovers which went to Mars in 2004. It was a huge hype. These are till now the most successful mission ever done by any human being or any organization till now on Mars. So they discovered this. This was Spirit. It actually discovered such storms, tornadoes. These are huge, gigantic tornadoes which happen in Mars. They are the best vacuum cleaners in our solar system. Like that, I can go on giving a details that first what we understand by sending rovers or spacecrafts to Mars is the geology and a broader concept of geology and the broader concept of technology. What kind of technology is needed for our further exploration. But as I will also like to end my talk in a tone that, well, apart from technology, we have also thought about search for life. So for life searching, has Mars helped us? Obviously. Before searching life, we need to find water. As we know life in our own Earth, we should find liquid water. Do liquid water exist in Mars? Now you just see with these few slides that how this was solved, this question, which is a very difficult question. How will you actually prove that Mars has liquid water presently or not? But by sending rovers, by sending orbiters, we have actually found something. See, this was during 2000 when Mars Global Surveyor first gave this picture where you see some gully-like features. And the scientists claimed that these features are actually gullies and these were carved by some distant water flow. Naturally, they were skeptics. Somebody didn't believe it. Some group of scientists. They needed more proof. How can you tell like that? In 2002, Mars Express orbiter, it also pointed that no. We feel that liquid water till now exists in Mars. And later, when the Spirit and Opportunity went to Mars in 2004, one day suddenly while roving, the rover Opportunity found some rocks like this. These are basically known as blueberries. And these blueberry rocks were found in a region which is known as Endurance Crater. So many such types of round-shaped rocks are there. And gradually scientists became very much sure that such kind of rocks can actually form in a place where stagnant water was there, like a lake or like a stagnant pond, a small river or small, not river, small pond or small lagoons or like that. That otherwise this kind of rock features cannot form. But still there are skeptics. Well, whatever you say, you are just giving the proof that, okay, might be water was there. But is water present in Mars now? So let us see now. Then came in 2008, Phoenix lander. It was not a rover. It was a lander. And in 2007, actually 2008 June, it dug one area in Mars soil and it found some bright patches or bright rock-like structures here. So it was on the 20th day of its operation, Phoenix, and after 4 days, on the 24th day, it took the picture of that same area, and you see those bright white patches have vanished. What it can be, the most logical conclusion is that these patches of bright features are actually water ice. Okay, people understood. Okay, no. We are actually understanding that. Okay, with such sophisticated instrumentation of Phoenix, you are actually getting water ice. But is water present? So see, this is a actually collage or actually an idea. What kind of instruments generally are carried by rovers or landers? Naturally, most of the instruments are focused on camera, imager, analysis of soil, analysis of various composition, analysis of other features, rocks, and also analysis of life. So for life, we can find some compounds or we can find some elements and biomarkers. So these are some components or these are some instruments which are carried out or which are carried nowadays also by rovers. Now, this was up to this level, we knew that, okay, water ice exists. What about water? Not ice. And ultimately, not going to much details, I will come to this, that Mars Reconnaissance Orbiter in 2011 firmly confirmed that, okay, they have observed, as scientists of MRO, they observed these dark colored features, and these dark features are coming out from these craters or some crater or highland regions and flowing towards the lowlands. And for one Martian year, that is for 2 years, the same regions were multiple times observed. And these dark features were observed during the summertime, they are actually observed. And it was found that during winter time, these dark features have vanished. The most logical conclusion, through logically understanding and through analysis, so many other doubts were cleared, so many other probable conclusions were not taken into, because that cannot happen. So the most logical conclusion, how or why these features are vanishing, is that these are basically flow of water. These are streams of flowing water which are appearing during summertime as ice in some places are actually melting, and during winter time these are again becoming frozen, and within some time when it is exposed to sunlight, they are actually, this water is sublimed. So that is why water is vanishing. So these are till now the best evidences which we have received, which tells us that Mars in some cases has free flowing water, liquid water. So this is how, with the help of extreme sophisticated instrumentation clubbed with scientific knowledge and pursuit, we can actually tell about Mars. And if life we have to find water. What about life? Have we found life? So for finding life, you will see that so many meteorites fall from sky to our Earth in various places. Among those meteorites, some of them, it has been proved that some of them in distant past came from Mars itself. And one particular meteorite which fell in actually Antarctica around 13,000 years ago, that was discovered by some team in 1984. By analyzing this meteorite, the scientists in 1996 told something which is a startling announcement. What was that? They found through microscopic studies and analysis some structures like this which are appearing like actually microscopic organisms, microbes. Though presently we know that basically these microbial organisms which we feel that, okay, these are coming from Mars, and in Mars these microbes are there, that means life is there. It's not so easy. Presently, scientists predict that these are not actually signatures of life or microscopic organisms. This can happen due to various conditions which are present in Antarctica, due to contamination in Antarctica, ice. So we cannot take it as 100% evidence. But Mars every time has given us an indication that it is the most favorable place where life can sustain, but might be in the format of a very extreme form. And the last example which I would like to highlight here is by this team of Rebecca McCall, which they did an experiment in our own Earth. What they did was they actually created in test tubes extreme conditions, and they put some extremophile organisms which are known as methanogens. Now these methanogens are found in basically in various places in Earth, and these are anaerobic in nature. They basically do not need oxygen for survival. They do not need much amount of food. And this team actually proved that by creating the conditions of Mars inside this test tube, these methanogens actually survived. So they claimed that, okay, if any life form can survive in Mars, that can be in the format of methanogens. Surprisingly, my friends, we have found or we have detected an ample amount of methane existing in Mars. And as a result, when our mission, Indian mission, Mars mission, Mangalyaan, when it went for studies, it has one component or one payload or instrument which is known as methane sensor. It has 5 instruments. One of them is methane sensor. So these sensors for detecting methane, if we find ample amount of methane, that can be a signature that is created by some microbial life. So this is how the search is going on presently. And the future is obviously exciting, as you know, that so many other, like Perseverance, so many other or rovers will go, like ExoMars. So many other missions are planned now by various agencies, including our own India. And there is one plan that, well, this time we should gradually plan to send one particular mission to Mars, which is basically this Perseverance, which has already started its journey in July, week of July. So if everything is all right, it will go there. It will collect some sample of soil and some amount of soil. It will keep it there. And later, some other mission will go to Mars and bring that soil, Martian soil, to our own Earth, so that we can basically test every condition of Mars, or we can basically test that soil in our own laboratory, not by remote control. So a lot of missions have been lined up like this. I am just giving one very crude estimate of this. So if you see about this ExoMars trace gas orbiter, which is also lined up basically, it will also start its journeys, might be very soon. So any kind of trace gas or any kind of signature from the atmosphere, from the soil, from the rocks which we find, which can be generated as a byproduct of life, we are trying to find. And basically, outside Earth also, we have found at least few planets. One of them was very famous few years ago, TRAPPIST system. So another was this Kepler 186 system. So where we found one planet like this, it's having almost the same size of Earth. It is also in that system of planets, it is also located in the habitable zone of that star. So naturally, our idea of searching life is gradually increasing day by day. Though it is very difficult to search life outside our own solar system, but we are finding that, yes, life may not be an accident. It can be there. And basically, I will end my talk with this, that basically you see this last thing, when someone maybe during prehistoric time were also looking at sky, thinking that, okay, whether we are alone or not. And now also we look at the same sky with better eyes, with better instruments, and think about the same question: are we alone in this universe? Only I would like to say that in this endeavor, we are progressing. We have progressed a lot, we have learned a lot, and we will go on. And Mars has been a key player for this understanding what we have received now. Before ending, I would like to thank again RoverX. So in this endeavor of searching life outside our Earth, this RoverX team, or a young batch of UG students from Vellore, there are also some other teams who are working in some other universities of India also. So especially this RoverX team has designed one prototype of rover which might be sent to Mars in future, and it will also help in this endeavor. And their rover basically was judged as among one of the top 10 worldwide in worldwide competition in University Rover Challenge. They gained among one of the top 10 rovers which they have already developed. And this is a very recent news, which is in 2020. And I hope that this particular rover which they have designed is known as Yuvan, Yupan. So in this endeavor, I am happy to say that the team with which I am talking to, the team for which I am giving a talk, they are also a part of this extremely courageous endeavor of searching life outside Earth. I would like to stop here and I will open for questions if there is any.
Thank you so much, sir, for this very enlightening session. And we would take this time to pick your brains a little bit more and ask you a few questions that were submitted by our team members. So we'll go ahead with that.
Yes, sure.
Fine, sir. So when we have several rover missions to Mars, and so the question we have is, what exactly are we expecting to find from these rover missions? When we say that we are trying to find the presence of life on Mars or the possibility of existence of life on Mars, what exactly are we trying to find?
Yeah. So basically, yes. First is we try to find the ingredients, the bare necessities of life as we understand in our own Earth. So as I have already mentioned, that the first thing is that you have to find not water, not life exactly. You have to find what conditions life exists in Earth, what are the normal conditions, and that kind of normal life, if it is existing on Earth, that these life will obviously will be composed of some ingredients, which I have mentioned, 6 main ingredients. Then they will also actually produce some byproducts. So suppose if there is life in Earth, you will see from this life, methane is generated as a byproduct. These are actually known as biomarkers. Also, these kind of byproducts, or which are known as biomarkers, and basic ingredients of life we have to find first. This actually is going on. If you look at this Curiosity mission, so basically in 2014, Curiosity mission actually confirmed the existence of methane in Mars. It also confirmed the existence of some other compounds in Mars, which are extremely important. In 2005 and 2003, European Space Agency, their Mars Express rover, they also confirmed the presence of another light gas, which is known as formaldehyde. So that gas is also a byproduct of life, basically. But just by finding that, we cannot be sure that, okay, life is present, that's why it is happening. So that means if we are finding some biomarkers, we have to be very sure that that is coming from life, or there are some other processes which are gradually giving rise to this kind of false alarms. So that means basically the biomarkers or the ingredients, the basic ingredients, these are the first thing we have to search for. And mainly all the rovers, all the missions, they whenever we tell that this mission is going for, or this rover is going for, one objective is searching life, that means they are trying to find the ingredients and they are trying to find the signatures of life, biomarkers, like that.
Okay, thank you,
Right,
sir.
A very small request.
Sorry.
Could you please stop presenting the screen so we can get you on the full screen?
Yes.
Thank you so much, sir.
So, thank you for that answer, sir. So on rovers, we have instruments. So my question was that what kind of data do we receive from the instruments, and what all experiments are carried there, and why do we carry those experiments?
Okay, data. See, first of all, we have to take data in the format of pictures. So one major data which we get from any rover, any mission of Mars or any other planet, basically, is pictures. High class, high resolution pictures. As you might have seen that by taking high resolution pictures, how can we actually understand the geology, the surface of that particular planet? Second is, after we understand what kind of surface feature exists, what kind of geology exists, what is the composition of the atmosphere, where are the places where a rover can actually land and work. So after that, if this is known, then only we can actually fix some of the particular instruments taken care by that particular rover for that particular objective. So suppose if I take an example, Curiosity. Curiosity is one of the main objective was to search life in Mars. So that means for complementing with that particular objective, it has taken some particular instruments like camera, soil testing instruments, sensors, detectors, and then gas chromatographs by which it can analyze the gas and it can tell what is the composition of the gas and whether that composition is matching or not with our own Earth's composition of that particular gas in that particular volume. If it is matching exactly, then we can tell something that, okay, if there is so much similarity with Earth, then whether life is there or not. So like that. Then also rock testing. For rock testing, there are so many sensors which we use nowadays. So like that. So that means basically in a broad way, I will tell you this is actually dictated by not by the rover itself, but by the objective. So what objective we want to fulfill, and by that, to contemplate that objective, what kind of instrument we have to carry. Take, for example, our Mars orbiter mission. So it was a orbiter and it carried 5 instruments. One was camera, one was thermal sensor, one was methane sensor, contemplating with the particular objectives like that.
Yeah. Thank you, sir.
Anything else?
Yes, sir. It's almost criminal not to mention Elon Musk and his brainchild SpaceX while we're talking about Mars. And we currently have the privilege of living in a very exciting time with Elon Musk promising to put us on the red planet before the end of this decade and setting up a colony before 2050. So how realistic are these goals in your opinion?
Well, I will suggest, see, the way Elon Musk and their SpaceX team is working means, see, it is, I don't think that it will be unrealistic because the way they are progressing, who knows, means no one can predict the future actually. So it's not that I will tell, okay, 5 years later, this will happen, that doesn't happen, doesn't mean that after another 2 years, they cannot do that same thing. But obviously, I have positive feelings for this. If not 4 years or 5 years, obviously by 8 years, 10 years, it will be successful. Because this is what we have seen in history, actually. So the first Mars lander took around 15 attempts to land. Before that, more than 10 landers or 10 orbiter missions were actually lost. But now we are successful. So, well, obviously, the way they are progressing, I can bet that they will be successful very near future, my way.
Sure. Thank you, sir. So the Perseverance rover will collect soil and rock samples for later testing of evidence of life, right? So, but there are only limited number of test tubes there. So, what makes a Martian soil, good enough for caching?
Yeah. Basically, for Martian soil, might not be. I should not comment in deep in this aspect as I am not an expert in this field. But basically, what I can tell is this: while choosing Martian soil, you have to, this particular lander or this particular rover will go a place in Mars where before only we have found some signatures of water flow. We have found some signatures where river flow was there in ancient past. So basically from those places, if we take soil and if we analyze that soil properly, then we can expect about some signatures of or biomarkers or byproducts of life or byproducts of past life if it exists. This is one issue. Second issue is, if you look at this history of Mars exploration, so many times by fluke only, by coincidence only, we got something new. Like example, discovery of these blueberries. This was a by fluke mission. Like discovery of water ice by Phoenix. So we didn't know that the place where it is landing, just near it will dug the hole and there only we will find water ice. So naturally, obviously geology, understanding the geology has helped us a lot. So that is the basic point. After understanding the geology and surface features, it will be landing in a place where we can expect such kind of soil to exist, where we will find traces of past, not life, past water. And if water flow was there, then we can expect that, well, it will tell something more, especially with gas chromatography testing, with sensor testing, soil composition testing, and obviously spectroscopic testing of soil, composition of soil, ingredients of soil, like that. Yeah. Anything else?
Right, sir. Yeah. So the Indian government has announced several reforms promoting the privatization of the space sector in India. What are your views on this? And do you believe this will help India find their feet in the space race?
Okay, that is a critical question. Okay, okay. Yeah, nice question. But actually, see, it's not about my belief. I feel that, see, if we honestly do these things, yeah, then privatization of space sector a little bit or a part of it might help us, because it's helping for case of SpaceX. So I am not against privatization. Also, I am not against any government or agencies. But as a whole, if we can work together in a collaborative manner, if the private sector which is coming for space development, if that is collaborating with other scientists, ISRO, and they are doing good work, then that will be obviously a benefit for our country. Not only for country, it will be a benefit for, might be, the whole humanity. So it's not that means only government agencies doing something good, I will just tell, okay, only government agencies should remain. I am open in this aspect. If private companies are coming or privatization is happening up to a certain limit, and they are also doing some good work with honesty and with good collaboration, then it is good. I agree with it. Yeah, if they are not doing good work, then I cannot agree with it. That is the thing.
So we'll take a question from the chat box. There's a very interesting question. So it says that why are we following the sponge thing? Like, because Mars might have many different kind of, a life. It's very different from that of Earth. So why are we just concerned about the sponge?
Yes, that is a nice, very curious, nice question. Actually, see, when we try to study something, when we try to know something which we don't know, suppose life, what is life? So this is new to us basically. So how we are trying to know about life? We are trying to understand life as we know it in our own earth, first of all. Because see, if we find some life form, not only in Mars, anywhere in, suppose in this solar system or outside solar system, which is basically made up of this particular 6 ingredients, we hope that we will be able to detect that those particular life forms are basically life. But suppose this question is a very nice question. It comes in this kind of talks. Suppose any other format of life is existing in Mars or somewhere else. Suppose you see you are sitting somewhere, my table is there, and basically this table is also alive, and we don't know about it. And it is completely composed of something else. Right? Not these 6 components or 6 elements, it is completely composed of some other 6 elements. So in that case, we will not be able to detect life until that table starts jumping and says that, okay, I am live, I am also live. Otherwise, we will have to restrict ourselves according to the knowledge which we have till now. Yeah, after that, I am not at all telling that other forms of life cannot exist. But that other form of life, if that does not tell us, okay, I am live, then we will not be able to detect it, considering our present knowledge. Yeah, this is the thing.
Right. So also we have another interesting question coming to us from the live chat. So the person is asking that how do we exactly know that a meteoroid is from Mars itself?
Yeah. Very nice. Yeah. Very nice. Actually, I didn't discuss this. See, so basically, if you till now, more than 50,000 meteorites which we have found in our Earth, which has been analyzed, 120 of them are coming from Mars. Basically, how will you know that? There are so many processes, mainly by testing the composition and matching, or actually analyzing the composition, comparative study of the composition of that particular meteorite with that of Mars. So for example, that particular meteorite which is coming from Mars, we expect if that meteorite came from Mars, we know the age of the meteorite, around 300 crore years ago it came. So 300 crore years ago, what was the composition of Mars? We have an idea about that. That time iron oxide was not present. Yeah, so rust was not present in Mars. So that time, if we have that compositional idea, we can test that particular meteorite to see what kind of composition this particular meteorite has. Same thing happened in case of the rocks which we brought from moon. So when we studied those rock samples, as according to our present understanding, we know the best theory is this: our moon was produced from our own Earth due to a huge collision some very distant past. So what we can predict from this idea, we can predict that the composition of moon in some cases will be similar to that of Earth, at least some of the surface layer compositions, some of the inner layer compositions. And if we find a rock which is having almost a similar composition analytically with that of moon, then we can predict that that particular rock is from Moon. The similar kind of analysis is done in case of Martian meteorites. With so many other details. There are spectroscopic evidences, there are other sensor-based technical evidences, there are basically geological testing and compositional testing. So many things are done, but basically finding similarities of that time of Mars from where it originated, from the time where it originated. If we find that similarity, then we can confirm that yes, it is coming from Mars.
Thank you, sir. I would actually like to thank everyone who's putting questions in the live chat. We are going through it, so please keep asking questions if you have any. There's one more. Is ice on Mars made up of light water with one hydrogen atom and one oxygen atom?
Basically, and another good question. Yeah, I didn't tell about it. See, basically, ice on Mars is basically when you see the north ice polar cap and south ice polar cap in Mars, North Pole and South Pole. Basically, ice in South Pole is made up of carbon dioxide, South Pole ice. But when you go to Northern Hemisphere or North Pole, there is carbon dioxide ice, but a very minute fraction of that ice is also made up of water ice. So the basic composition of ice in Mars is basically carbon dioxide. So basically that is dry ice, extremely cold, extremely cold. So this is mostly dry ice, carbon dioxide ice.
Right, so we have one more question coming in from the chat. So Andy is asking that is it actually possible to cultivate in Martian soil, or is it just a myth?
Presently, see, it is a myth according to our present knowledge or present understanding. So if you see that movie, The Martian, so which was, I guess, in 2015 it came. So in that movie, obviously they have shown so beautifully. I like that movie, but obviously they have taken some cinematographic license. So if you go there now, presently you cannot cultivate because we need to do something known as terraforming. So that means changing the surface of another planet or another body outside Earth in such a way so that human beings can stay. So for that, if you can terraform Mars in such a way or a part of Mars in such a way, then only you can actually cultivate crops and all these things. With our present technology and understanding, we cannot. This is not possible presently. But it might not remain myth after 20 years or maybe 30 years. This is the thing. Science progresses like this.
So there's one from our teammates. So what parameters are considered when choosing a specific instrument that we use on a rover?
Basically,
experiments for conducting.
So obviously considering all other parameters that, okay, we are sending this particular instrument because we need to do this kind of works with the help of this instrument. That I am not mentioning. Obviously, that is scientific part or technical part. But basically, whenever we select an instrument, that should survive the conditions on Mars. So if you go to Mars, you will see wind flows at speeds of more than 300 kilometers per hour. Various times. We have recorded that wind speed through the help of the audio recorders of Spirit, Opportunity. But so that means what? Whatever instrument you are sending, that should have the basic capability to withstand the conditions which is present in Mars. There is extreme amount of iron oxide. So if you send one instrument very simply on iron instrument, it will not sustain much. There are so many other aspects. Dust flow is there. You have already seen that there are global dust storms which occur. So we have to select instruments in such a way that after global dust storms are occurring, that global dust storm should not deposit much amount of mud or much amount of dust on the surface of the instrument. So like that, so surface smoothness, then calibration, then sophistication of the instrument, resolution power. These are some of the parameters. Then it's sustainability capability, portability capability. These are some of the aspects which are taken care of. There are, without going to the details of other technical issues, I am telling this. So these are some of the basic aspects which we take care of.
Right, sir. So we'll go ahead with one more question. So you mentioned exoplanets in your talk, and so the question we want to ask you is why Mars? We have several Earth-like planets within the Milky Way galaxy and in our universe. Why are we focused on colonizing Mars?
Basically, yeah, it is also a good question. See, basically because of, we have found exoplanets, but we cannot go to exoplanets now. So basically, the problem is our knowledge, our limit of knowledge, distance. Another problem is distance. See, you cannot break the barrier of physics and go to an exoplanet within 10 days. Yeah. So that is restricted by nature laws. And secondly, why in our particular solar system, why on Mars specifically, that I have already shown, that it is the only place in our solar system which appears to be just tipped away from the habitable zone of our Earth, of our solar system. So as sun will progress in distant future, when sun will become a evolved star, when it will become a red giant, so gradually the habitable zone will shift, and it will shift in a further area. So naturally during those days, maybe crores of years later from this time, one day will come, if Mars is there, then Mars will become a habitable planet, or Mars will come into that habitable zone of the distant future sun. And also from the present point of view, we see that it is the only planet which appears that somebody has just knocked it down from the right place. It's just one stair down, sitting away from the habitable zone. So naturally it gives us that opportunity that, oh my god, we should search Mars first. Apart from any other place, this is the most probable place where we can expect life forming condition, or life, or even life forming other ingredients, like that. Might be in present times or might be in future times. And also another thing is that it is now very well established fact that Mars during distant past, it was a wet Mars. Mars had watery wet past. So there were huge water flows in Mars, extensive floods. This has been proved. So if water flow was there, then in distant past was life present? That is another question. So these interesting aspects have come to us as we started understanding our own solar system. And so this makes Mars special in our solar system. And out in the whole universe, it is, I will not say it is special. Till now, we cannot go. We cannot travel outside our solar system presently. So if we find exoplanet also, these are so far away, there is no other way. First, we should study our neighbor red planet. This is the thing.
So, how do we choose
Very
the
true,
type
sir.
of rock? Sorry.
Yeah,
So how do we choose the type of rock that is suitable for later analysis?
how do we choose a type of
Type
rock?
of rock
Or,
that is used for later analysis.
yeah, so again, I will, this is a similar kind of answer I would like to give. See, there are so many constraints. Always we will choose a rock for later analysis. This might not happen in Mars or in other planets. So whatever, see, when human beings went to moon, they were not given this idea ki, okay, you should choose this kind of rock. Whatever you find, pick it and bring it to us. It's like this. It's some type of randomness is there. But it should land in a place where we should find rocks, or where we should find soil or structure of soil which we have either studied before, we have some idea about that area, and that is why we are landing that particular mission into that particular place. But choosing rock is actually not taken care of by some preset destinations. So I will give you an example. Spirit and Opportunity send us pictures, more than 7 lakh pictures, and they have studied more than 22,000 rocks. And out of these 22,000, they were all randomly chosen, basically. And we have found so many things like that. So it's, we cannot fix like that. Okay, if you choose this rock, then we will find something. That will not happen. This knowledge is vast. Yes.
Right, sir. Do we have any more questions, Kadambari, from the chat?
As far as I can see, I don't see anything. So actually, there's one last question that we would like to ask before maybe stopping. If one wants to pursue a career in astronomy, how could they go about doing it?
Oh, okay, yeah, that is an interesting question. I basically, okay. So what I will suggest is, see, there are options nowadays. We are living basically in a golden age of astronomy. There are so many options. So first of all, you can see, basically there are two options. Either you should go through engineering stream, or you should go through basic science stream. So basic science means you should have physics in as a subject, and in engineering means obviously it will be good if you have electronics or electrical mechanical, some core or computer science, some core engineering related background. So I also did my engineering and then shifted to astrophysics. My engineering was on electronics and instrumentation, BTech, and then I did my master's in astronomy and space engineering. So that option was available during that time in India in Manipal University. But this kind of option is also present nowadays abroad also. So either you will have to shift to through engineering and then you can go to astrophysics background, or you can shift directly from BSc or bachelor's in masters in physics and gradually shift to your astrophysics area. But before, see, this is a very small answer which I am giving. I would like to share the screen once more just to give an idea. Luckily, I have a slide for this. So if anyone in details wants to know that, well, what should I do if I want to become an astronomer or space engineering, just reading like that might not help. So I will just refer that one might go to Amazon and buy this book, because basically this is a self-advertiser when for me only I am doing, somehow I will say. So this is a book which I have written particularly to answer this question. So this is a question which I have faced not many number of times, and naturally within 5 minutes I cannot describe how can you become an astronomer or space science engineer. So that is why I felt that in India these kind of books are not available, which will be basically not to teach astronomy to anybody. That astronomy book is available so many, but how can I become an astronomer? This is a book for that particular, solving that answer. How you can become an astronomer, what you should study, how you should study, what are the project aspects, what are the ways by which a person can remain as an amateur astronomer. If you do not come to a professional astronomy also, you can contribute in various ways. So all these questions are lucidly solved here. So it's in the format of, it's basically a guidebook, how you can become an astronomer. I will refer that if anyone likes it, you can have a copy of it and you can look into it. So, yeah, this is the case.
Right, sir.
All right, so thank you so much. It was such a wonderful presentation, and the question answer series. I'm sure we both had a lot of fun just asking the questions, and the way you answered it. It was just fabulous. And I would personally like to thank you for all the efforts you put in to share your knowledge today. And it was great to have you. And I really hope to, maybe listen again from you sometime. And
Yeah,
thank you very much.
thank you very much. I also thank the whole team, the organizers, also VIT, and might be we will again meet one day. Yeah, thank you everyone for organizing this.
Yes, sir. So on behalf of Team Rover X, I'm obliged to thank Dr. Vino, the faculty coordinator of Creation Labs and the Office of Student Welfare, for giving us this wonderful opportunity to host this event. And last but definitely not the least, the viewers. We are sincerely grateful that you took the time out and joined us on this virtual platform in pursuit of knowledge. And we really hope that you enjoyed this session as well. Thank you again.
Thank you, sir.
Thank you.